Welcome to my channel. Today we are going to continue with the 2020 further mathematics questions. Okay, so sit back, get your pen and paper, let's start. All right, let's start with question number 9. We have number 9a and number 9b. The A says if x plus 2 is a factor of g of x, and the function g of x is 2x cubed plus 11x squared minus x minus 30, that we should find the zeros of g of x. Zeros of g of x are values of x that will make this function to be equal to 0. Now the B says that we should solve two equations. This is the first equation is 3, open the bracket, 2 raised to power x, you close the bracket, plus 3 raised to power y minus 2, which is equal to 25. And then the second equation is 2 raised to power x minus 3 raised to power y plus 1 equals to minus 19. We have to solve these two equations simultaneously. Now let's solve them. Okay, let's solve 9a. Here we have our number 9a. G of x is given. So here is our g of x. We have to find its zeros. Okay, now to find the zeros of x is just to find the values of x that will make this function to be equal to 0. So to do that, I start by dividing g of x, okay, by the factor given is x plus 2. X plus 2. So let's do that here. It's already done, just to show you how I did the division. So here I'll have g of x, and that is 2x cubed plus 11x squared minus x minus 30. That is our g of x. Here I'll have my divisor, that is the factor given, x plus 2. Okay, so this 2x cube will be divided by x, and that will give us 2x squared. Okay, I'll multiply 2x squared by the factor, and that gives us 2s cubed plus 4x squared. Okay, if I subtract, I'll have minus 30 because it has no like term, and I'll also have minus x because it has no like term. Then 11x squared minus 4x squared will give us plus 7x squared. Okay, 2s cubed minus 2s cubed is 0. So we'll come over to this side and divide 7x squared by x, and that will give us plus 7x. Okay, so we'll multiply 7x by the factor x plus 2, and we have 7x squared plus 14x. We'll also subtract, and that will give us, we'll bring down 30. Okay, x minus x minus plus 14x is minus 15x. Okay, 7x squared minus 7x squared will give us 0. Alright, we'll divide minus 15x by x again, and that will give us minus 15. Minus 15 multiplied by the factor x plus 2 gives us minus 15x minus 30. We'll also subtract to get 0. Yes, the remainder should be 0 because x plus 2 is a factor of g of x. Now we have our quotient, which is the quadratic, which is 2x squared plus 7x minus 15. That is the quotient. Okay, and x plus 2 is a given factor. So we'll factorize this. If you watch my video on factorization of the quadratics, you will learn how to factorize every quadratic given to you. So in factorizing this, we have 2x minus 3 and then x plus 5 as the factors of the quadratics, whereby x plus 2 is the given factor. And these are three factors of the given g of x will now multiply to give us 0. And this simply means that x plus 2 is equal to 0, or 2x minus 3 is equal to 0, or x plus 5 is equal to 0. Now if x plus 2 is equal to 0, it simply tells that x is equal to minus 2. And if 2x minus 3 is equal to 0, it simply tells that x is equal to 3 over 2, which is 1.5. Then if x plus 5 is equal to 0, it means that x is equal to minus 5. These are the zeros of g of x. Okay, these are the zeros of g of x. So try it out and drop your comments if you have questions. Alright, let's solve question 9b. What I did is to call this my 2 raised to power x p and then 3 raised to power y q. So in place of 2 raised to power x here now, I'm having p, and that is 3p here now. And then for this particular 3 raised to power y 3 raised to power y minus 2, this is it, 3 raised to power y times 3 raised to power minus 2. And remember, 3 raised to power y is q times 3 raised to power minus 2. So this is it here. Okay, so substituted, and then all is equal to 25. So we have our equation 1. For the number 2 equation, we have 2 raised to power x already here, and this is 8p. And then to simplify this, I will have a 3 raised to power y multiplied by 3 raised to power plus 1. And this is the same as q times 3, and that is 3q. Okay, and that is what we have here. So this is it here, and all is equal to minus 19, and that we'll call equation number 2. So let's solve these simultaneously in our next slide. Okay, here I solve the simultaneous equation using substitution method. Okay, so I have to work out for the second equation, which is p minus 3q equals minus 19. Here I made p the subject of the equation number 2, and I have p to be equal to minus 19 plus 3q. Now I will have to substitute this into equation 1. My equation 1 is 3p plus q 3 raised to power minus 2 all equal to 25. Okay, so in place of p now, I'm going to put minus 19 plus 3q. Okay, and then I'll simplify this further to get 3 raised to power minus 2 is the same as 1 over 3 raised to power 2, which is equal to 1 over 3 times 3, and is equal to 1 over 9. So this is our 1 over 9 now. 1 over 9q. Remember, they are all equal to 25. I'll open the bracket and I have minus 57 plus 9q. Then outside the bracket I still have 1 over 9q equal to 25. Collect the like terms. The q's are on the left and the numbers are on the right. We add the numbers 25 plus 57 and we have 82. So we'll make this a single fraction. So we'll make this a single fraction and we have 82 over 9q. Okay, we divide through by 82 and multiply through by 9, and we have our q to be equal to 9. And remember that q is representing 3 raised to power y. And since our q is 9, we'll reduce reduce 9 to index form. Okay, we simplify it, and then we have 3 raised to power 2, and that tells us that our y is equal to 2. Okay, our y is equal to 2. Now that we know our y, let's find what x is. Okay, to find x, what we do is simply put 9 in place of q. Okay, so in any of the equations, but I choose to do it where I already have p as the subject. So this is p equals minus 19 plus 3q q. So in place of q now I'll put 9. Okay, open the bracket and I have minus 19 plus 27. Do the arithmetic and I have it to be equal to 8. Okay, so that means that our p is equal to 8. Okay, so remember p represents 2 raised to power x. So we'll put 8 in index form and we have 2 raised to power 3, and that tells us that x is equal to 3. So x is equal to 3 in that simultaneous equation, and y is equal to 2. So these are the values of our x and y in the simultaneous equations. Thank you. Okay, we are at number 10. Question number 10a is on differentiation, and we are taking the derivative of y. Okay, and here is our y, x squared, bracket open, 1 plus x then raised to power 3 over 2, and the derivative is with respect to x. Okay, that's our question 10a. Then 10b, we are told that the center of a circle lies on the line 2y minus x equals 3, and if the circle passes through the coordinates p is 2, 3 and q is 6, 7, that we should find the equation of this circle. So let's do that. Okay, let's solve question number 10a, derivative of y. Okay, y is product of two functions. Already I have a video on this. Okay, you can watch it and learn how to find derivative of product of two functions. So let's solve what we have here. I have two functions, then I will select one of the functions be called u, and that is x squared. Okay, and then the other one called v, and let's say is 1 plus x all raised to power 3 over 2. That will now make our y to be equal to uv. Okay, uv. Okay, so if I take the derivative of y with respect to x, I will use the product rule, which will give me v du dx, okay, plus u the v dx. Okay, already is done because this is our du, okay, and this is our v, and here is our u, and this is our the v. Okay, so factor out the common term there, and that is 1 plus x raised to power half. So others are in the bracket here. So we have like term x squared, s squared will simplify to have 7 over 2 x squared. So we'll work this out, this bracket now. We'll find the LCM here. This is like over 1. So we have 2, and then this will give us 4x plus 7x squared. Okay, so factor out the common, this factor there is 1 over 2 and x. Okay, and then we'll have 4x, sorry, we have 4 now, not 4x, 4, and then we have 7x. Okay, and this can as well be written as 1 over 2x 7x plus 4. So either ways you're still right. So that is what we have here, and then this is the first common factor, and then here also we have our 1 over 2x. So this is the derivative of our y. Okay, we are on to question number 10b, and we have the center of a circle that lies on the line 2y minus x equals 3 and passes through 2 points, points P and point Q. We have to find the equation of the circle. So let's say that the equation of the circle is with the center H as my x coordinate and K as my y coordinate. Okay, so I have the equation. This is the equation of a circle. Okay, and r here is the radius. Okay, this is the radius. Am I writing? Okay, this is the radius. Okay, so let's say it passes through P. So this is our P. Okay, for X we have 2, for Y we have 3. Okay, so I substituted in this expression, open the brackets, 4 minus 4h plus h squared for the first bracket. The second bracket we have 9 minus 6k plus k squared, all equals r squared. So we have h squared plus k squared minus 4h, and then minus 6k plus 13r squared is our first equation. Now the same circle passes through point Q, and this is our x, okay, and this is our y. Okay, we substituted in the original equation here, and we have 6 minus h squared plus 7 minus k squared equals r squared. So we have 36 minus 12h plus h squared plus 49 for the second bracket minus 14k plus k squared, all equals r. So that is h squared plus k squared minus 12h minus 14k plus 85 equals r squared for our second equation. So let's continue. Okay, continuing on this slide, we will solve equation 1 and equation 2 simultaneously. You can see it here. We are subtracting equation 1 from equation 2. So r squared minus r squared will give us 0. 85 minus 13 will give us 72. Minus 14k minus 6k is minus 8k. Then minus 12h minus 4h will give us minus 8h. Then k squared minus k squared will be 0. H squared minus h squared is also 0. So we have this remaining. So further we now divide this by 8, which if we do, we have minus h, okay, minus h minus k plus 9, all equal to 0. Okay, we take this over to this side, or we have minus h minus k equals minus 9. Okay, we factor the negative and we have h plus k equals minus 9. So the negative will cancel by dividing both sides by minus 1. So we have h plus k to be equals to 9. So that's where this equation 3 is from. Okay, remember our circle lies on a line 2y minus x equals 3. And we said let the center be h and k. So in place of x we have h, in place of y we have k. So we substituted, we have this 2k now minus h equals 3 to be our number 4 equation. So we solve 3 and 4 simultaneously to get h and k. So if we do that here now, we will have minus h plus 2k to be equal to 3. So let me add. Okay, so I can eliminate 1. This is now 12, and this will now give me 3k. Okay, this is 0. So I will now divide both by 3, and that makes k to be equal to 4. Now I can substitute in any of the equations. K equals 4 will now give me h to be 5. Okay, so now we know our h and our k. So let's continue on the next slide. Alright, let's continue. So I want to put the value of h and k in our first expression. This is our first expression. So I have it here. Let me show you. Our first expression is x minus h all squared, okay, plus y minus k k all squared equals r squared. Okay, that's our first expression, and this one is when it passes through p, and our p is 2 3. Okay, so we have this. So in place of h, I'll put 5. In place of k, I'll put 4. Okay, and then work it out. This will give me 9 and this will give me 1. So at the end, I'm having my r squared to be equal to 10. Okay, so now that we know our r squared, we'll go back to the equation of the circle. So we have now x minus 5 squared, y minus 4 squared, all equals to 10, which is our r squared. Now get the like terms together. We have the constant terms, okay, 25, 16, and 10. So this will come in and become minus. So that will give us 31. Okay, so we just arrange it the right form of our circle equation, and we have x squared plus y squared minus 10x minus 8y plus 31 to be equal to 0. So this is our equation, okay, of the given circle. So try it out and drop your comment. Thank you very much. All right, we are at number 11. We are making progress. The first question is on logarithm. We are to simplify logarithm. Okay, so you can as well visit my video on logarithm before you answer this question. Okay, but meanwhile, I'm going to guide you on how this particular question is being answered, or you can answer it. The second one is on sequence. We are told that the first and third and seventh terms of an arithmetic progression, that's AP, form 3 consecutive terms of a geometric progression, GP. And if the sum of the first 2 terms of the AP is 6, the first 2 terms of the AP is 6, that we should find the first term and also find the common difference. So let's go to the next slide and see how to solve this. All right, this is our 11A. So let's solve it together. Let me get a pointer first and then we'll start solving. Okay, so I have the numerator and the denominator. So on the numerator, I have all the log in base 2. So this is log 8 base 2, log 16 base 2, log 2 base 2. Okay, and this is log 16 base 4. Now we are going to start by simplifying this particular one. That's we have the coefficient of this log to be 4. So let's simplify it, and if we do, let me show you how. Okay, so I will get it now. This is the same as this. Okay, this is where I'm going to show you what I would do. Is log, okay, 2 raised to the power 4 of base 2. Okay, so I'll take this as the power of this 2. So that is what we have here. Okay, so with that now, I will now take 2 to the power 4 is 2 multiplying itself into 4 places, and that gives us 16. Okay, so that's where the 16 is derived from. Okay, so we have the logarithm rule, that log m plus log n is equal to log mn. Okay, and log m minus log n is equal to log m over n. Okay, so I applied it on this numerator since all of them are of the same base. So I'll take log base 2 out. Okay, Now for these ones that are adding, I'll multiply them 8 times 16. Then for the subtraction, it turns to division of the number, which is 16. So this will cancel and we are left with 8. So this is it here. So this is still the same. Okay, now let me explain for this one. Note that 8 is the same thing as 2 raised to power 3 because it is 2 times 2 times 2. Okay, so this can be simplified further as log base 2 raised to power 3 all over 16 is the same as 4 raised to power 2. Okay, all over log 4. We're trying to simplify, remember. Okay, so this is the same as what we have on this page now. So we'll now have 3 log 2 base 2 and then 2 log 4 base 4. Then log of a number that is the same with its base is equal to 1. Okay, so a can be any number. A is a number. Okay, so they have the log and its base are the same. So that's what we are having here. 2, 2, 4, 4. So both of them are equal to 1. So we are left with 3 over 2 here. So 3 over 2 is 1.5, which is what I have here, or 1.5. So that's the final answer. Okay, so try it and drop your comments. Okay, here 11b we have the first, the third, the 7th terms of the AP to be the 3 consecutive terms of GP. So that is to say that A, the first term, A plus 2D, the second term, and A plus 6D, the third term, are the 3 consecutive terms of GP. So if we are to find a common ratio, which we use R to represent, it will be A plus 2D over A equals to A plus 6D over A plus 2D. So this is it here. So we'll cross multiply to have A multiplying A plus 6D and then A plus 2D multiply itself. We'll open the bracket to have A squared plus 6AD on the side, and then on the right we have A squared plus 4AD plus 4D squared. Okay, we can simplify further, but let's continue that on the next slide. Alright, let's continue on the slide. So I carried this over to the slide. So I want to work on this first. Let me have them all on the same side, and I'll have A squared minus A squared, okay, then plus 4D squared, okay, plus 4AD minus 6AD, all equals to 0. So with that, now I'm going to have A square minus A square 0. This has no like term, so we have it here 4D square. Then 4AD minus 6AD is minus 2AD equals 0. So we call this equation 1. Okay, the information given in the problem is that the sum of the first 2 terms of the AP is equal to 6. So this is the first term, okay, and A plus D is our second term. Okay, A plus A gives us 2A plus D equals 6. We'll call this equation 2 for simplification purposes, okay. So we make 2A the subject and we have 6 minus D. Call this equation 3. Now I'm going to substitute this equation 3 into equation 1. So in place of 2a here, I'm going to have 6 plus d. Okay, if I open this now, I'm going to have 4d squared minus 6d plus this, multiply this will give us plus d squared, all equals 0. So 4d squared plus d squared gives us 5d squared. Okay, and then we have 6d remaining here, all equals to 0. So we factor d out and we have 5d minus 6 equals 0. So this is simply telling us that it's either d is 0 or 5d minus 6 is 0. And if 5d minus 6 is 0, it means that our d is equal to what? 6 over 5, which is 1 whole number 1 over 5. So that is what we have here. And that is our d is our common difference. Okay, so now we know the common difference, that is either is 0 or is 6 over 5. So let's find the first term. Okay, substituting d equals 0 or 6 over 5 for us to find the first term into equation 3. So equation 3 is 2a equals 6 minus d, which is what I have here. So, sorry, this is it here. So if I substitute 0 for d, I'll have this, and that means that my 2a is equal to 6. So divide both sides by 2, we'll have our a to be 3. So my first term is 3 when d is equal to 0. Okay, then for d equals 6 over 5, okay, we'll work it out, and we have our a to be 2 whole number 2 over 5. So when d is equal to 6 over 5, the first term is 2 whole number 2 over 5. So you can try these out yourself and then drop your comments and questions at the comment box below. Thank you very much for listening.